Chinese scientists have successfully created microbots that can penetrate the blood-brain barrier to take residence inside the brain with the mission of curing brain diseases such as cancer. The way this is actually accomplished is as absurd as it is effective. In this video I'll explain how it is done and what this will accomplish. You'll certainly be surprised. Back in March of 2021, a study was published on the website Science Robotics, in which Chinese scientists created magnetically controlled microbots which take inspiration from our white blood cells. These so-called Nutribots have just now penetrated the blood-brain barrier to deliver drugs to the infected brain cancer cells. Simply said, the blood-brain barrier is a highly selective border that prevents anything but regular blood from getting into the place where your brain's neurons reside in. These microbots surpassing this barrier is a very big deal. This is a very cool idea, says Liangfang Zhang, a nano-engineer and bioengineer at the University of California, San Diego, who was not involved with the study. I think that the overall concept is novel. It's interesting because it's new thinking about how to send useful data and cargo such as cancer-curing drugs to the human brain. He said, previous iterations of drug-carrying immune cells have failed to completely treat mouse brain tumors, likely due in part to slow speed at which they traveled to the disease site. To improve speed and control, researchers have endowed microrobots based on, as ridiculous as it sounds, sperm, bacteria, or red blood cells with magnetic material to externally guide them with magnetic devices. One of the questions scientists and the global community are asking themselves regarding this procedure is whether or not something that could potentially be injected into someone without being detected should even exist. Because aside from moving drugs into your brain to cure cancer, these robots could just as well read neural activity which in the future could potentially be decoded into what you were thinking. People are especially skeptical of this because the country that published this research is China. A country which could potentially greatly benefit from the ability to know what someone is thinking. But that's probably a topic for a whole other video in the future. The reason why these types of microbots are able to cross the blood-brain barrier while other similar microbots can't, is because of their similarity to human white blood cells that occur naturally inside of the human body. These certain white blood cells are granted special access to deal with infections and inflammation, making them good Trojan horses for getting drugs past this border. In previous studies, researchers have loaded brain cancer drugs into neutrophils and macrophages, which have a natural ability to scout out cancer because they swim toward higher concentrations of inflammatory chemicals released by diseased tissues. As an example for this procedure, the scientists successfully cured glioma, which is a type of brain cancer in mice. Dr. Wu and his colleagues designed neutrophil-based microbots that could be controlled by a magnetic field outside the body. This magnetic field is used to steer the tiny robots into place of the brain where the cancer is located at. As a safety measure, the nanoparticles were enrobed in bacterial membrane. Disguised as harmful bacteria, the nanoparticles were engulfed by mouse neutrophils, which is much more readily than bare nanoparticles. The bacterial cloak also prevented the premature leakage of drugs and made the particles less toxic to the neutrophils, the researchers found. While the nanobots were navigating through the bloodstream, they reached a speed of 16 micrometers a second, which is about 50 times faster than natural material occurring inside the human body. By monitoring the nanobots via a microscope, the researchers could direct them to move in complex orientations on an artificial substrate. To research the nanobots' inflammation-seeking ability, the researchers placed them in a gel with an inflammatory factor. The Nutribots migrated toward higher concentrations of the chemical at a speed on par with natural neutrophils. And in a model brain-blood barrier, nanobots penetrated mouse cells grown on a membrane to access glioma cells and release their drug payload upon exposure to inflammation signals. According to Zhang, the individual components of the study, the use of immune cells as drug carriers, magnetically controlled nanoparticles, and bacterial membranes as cloaks, are not new. But what they did is integrate these common individual components together and assembled them into a new system, he says. They developed a very unique functionality, that is, the long-range control of neutrophils. Of course, it could not only be used to treat cancer. Other diseases or even neurological issues such as depression or tinnitus could potentially be solved by now finally having direct access to the brain. You could even leave out the brain completely. Have them go through your body and treat any kind of cancer and not just cancer. But that would require them to have some sort of intelligence which they simply don't possess at the moment. But once they do, and can move around the body as a singular entity, the world of medicine and curing diseases will never be the same again. But before microrobots can be used to treat cancer in people, there are still a number of challenges that need to be overcome. One of these is improving the percentage of microrobots that make it to the tumor. Microrobots could accumulate in other organs or regions of the body, and the long-term side effects are unknown. But this happens for every type of microrobot, not just for this particular work. This is a challenge for everyone to overcome. Once the microrobots arrive at the disease site, another hurdle is making sure they deliver enough of the drug. You need to increase the overall drug payload inside, and you also need to control premature drug release. It takes time for the nanobots to get to the destination. You don't want them to dump all the payload before they get to the destination, because a single microrobot can't carry enough medication to treat a disease. Researchers are also trying to understand how they move as swarms, similar to the collective movements of groups of ants, fish, or birds. If you know the amount of the drug that you load per microrobot, you can control the drug dose by swarming these microrobots in a controlled way. So this is one of the challenges: how to transport multiple microrobots in a controlled manner and deliver them to a target location. Wu and his colleagues found that Nutribots formed chains of 4 inside the bloodstream, and these swarms swam about 5 times faster than individual bots did. But according to Medina Sanchez, other microrobot researchers are aiming for swarms of hundreds, thousands, or even millions. It depends on the target and location. You may need just a few or millions of them. It's not clear how the Nutribots swarmed in mice because current imaging techniques aren't good enough to track individual or small chains of microrobots in real time at high enough resolution inside of the human body. Another challenge for precise navigation of these tiny drug couriers in humans. So what is your opinion on this type of futuristic procedure? I personally believe that these robot-centric ways of dealing with problems inside our bodies will only increase as we can produce smaller and smaller electronics over time. The risks in privacy and stuff due to involuntary injections do pose somewhat of a danger though. Do you agree with this assessment? Please tell us your opinion in the comment below. I'd love to have discussions with you about it.
Because if you inject tiny robots into the bloodstream, they can get very close to all the cells and nerves and things in your brain, really close. So if you want to input information or read information, you do it through the bloodstream.
Thank you for watching AI News. We consistently report on the newest technologies that are shaping the future of our world. We'd appreciate you subscribing and watching our other videos. See you around and take care.